Welcome to the DIY Honda Garage channel. The DTC P0010 indicates a malfunction specifically in the Variable Timing Control (VTC) Oil Control Solenoid Valve A of the Honda Civic from 2016 to 2021. This component is crucial for regulating the flow of engine oil to the VTC system, which adjusts the timing of the intake and exhaust valves for optimal engine performance and fuel efficiency. The solenoid itself is typically located near the engine block, attached to the valve cover, and connected via a 2-pin connector. A malfunction in this component can lead to various engine performance issues, as correct valve timing is essential for efficient engine operation. Diagnosing this error correctly requires following specific procedures as outlined in Honda's diagnostic guidelines, ensuring accurate identification and rectification of the problem. Addressing this error not only stabilizes engine performance, but also prevents further mechanical complications. The DTC P0010 signifies a malfunction in the Variable Timing Control (VTC) Oil Control Solenoid Valve A. This solenoid plays a vital role in controlling oil flow to the VTC system, which adjusts the timing of the engine's intake and exhaust valves. A diverse range of issues can arise from a malfunctioning solenoid, including reduced engine power, increased emissions, and potential engine stalling. The solenoid is situated near the engine block, usually attached to the valve cover through a 2-pin connector. Complications in this area can create drivability concerns, prompting further investigation. It is critical to address and rectify any issues with the VTC solenoid to restore optimal engine efficiency and performance, subsequently improving overall vehicle reliability. Several potential causes can lead to the activation of DTC P0010. A faulty VTC solenoid is the most direct cause. If the solenoid fails to operate correctly, it cannot regulate oil flow effectively, resulting in abnormal engine behavior. Additionally, wiring issues such as poor connections, frayed wires, or short circuits can disrupt the operation of the solenoid, causing it to malfunction. Another possibility is a malfunctioning powertrain control module, PCM, which might not properly send or receive signals essential for the solenoid's operation. It is also worth considering if any external factors, such as debris or contaminants, have affected the solenoid's performance. Understanding these possibilities helps pinpoint the exact issue and implement the appropriate remedy to resolve the DTC. Several symptomatic indicators accompany DTC P0010, primarily affecting the engine's functionality. A rough engine idle may be noticeable, indicating that the engine is struggling to maintain stable operation due to timing issues caused by a malfunctioning VTC solenoid. Drivers might also experience decreased engine performance, which can manifest as sluggish acceleration or lack of power during driving, severely impacting the overall drivability of the Honda Civic. Additionally, the check engine light, CEL, will illuminate, alerting the driver to the presence of a diagnostic trouble code that requires further investigation. Recognizing these symptoms promptly can prevent further mechanical complications from arising and ensure timely maintenance is performed on the vehicle, thereby enhancing overall vehicle reliability. The initial step in troubleshooting DTC P0010 involves verifying the issue through the onboard diagnostic system. Begin by turning the vehicle ignition to the on position without starting the engine. After that, utilize the Honda Diagnostic System HDS to clear the diagnostic trouble code DTC. This process resets the vehicle's fault memory, allowing for accurate testing. Subsequently, start the engine and hold the engine RPM at 3000 without load until the radiator fan activates. This procedure ensures that the engine is operating at an elevated temperature, necessary for the VTC system to function effectively. Following this, check for any pending or confirmed DTCs using the HDS to confirm whether the P0010 code has returned, indicating that the issue is persistent and needs addressing. Following the confirmation of the DTC P0010, the next step focuses on examining the VTC Oil Control Solenoid Valve A for internal resistance. Begin by turning the vehicle off to ensure safety during the disconnection process. Next, disconnect the 2-pin 2P connector linked to the VTC Oil Control Solenoid Valve A. Once disconnected, measure the internal resistance between the two test points on the solenoid valve using an ohmmeter. The specified resistance should range between 7.01 to 7.75 ohms at room temperature. If the readings fall within this specified range, it is indicative that the solenoid is functioning correctly. However, if the resistance does not meet these criteria, the solution is to replace the VTC Oil Control Solenoid Valve A to resolve the issue effectively. Continuity testing of the power ground PG line is the next step in the systematic troubleshooting for DTC P0010. Keeping the vehicle in the off mode, check for continuity between the two test points located as follows. Test point 1 is the VTC Oil Control Solenoid Valve A connector pin 2, while test point 2 connects to the vehicle's body ground. This continuity check ensures that the PG line is intact and able to provide a reliable ground for the solenoid operation. If continuity is established, it confirms that the PG wire is functioning correctly, and the troubleshooting can proceed to the next step. Alternatively, if continuity is absent, it indicates a potential open circuit within the PG wire, necessitating a repair before continuing with diagnostics to ensure the solenoid receives proper grounding to operate. The fourth step involves checking for a short circuit in the variable timing control VTC inline, which is essential for the proper functioning of the solenoid valve. Begin by jumping the SCS service check signal line using the HDS, allowing the system to enter into diagnostic mode. After a minimum wait of 1 minute, disconnect the PCM Powertrain Control Module, Connector E, ADP for safety. Then, measure the continuity between test point 1, which is at the VTC Oil Control Solenoid Valve A connector, pin 1, and test point 2, which is connected to the vehicle's body ground. If continuity is present, it indicates that the VTC in wire is functioning correctly, and attention can then turn towards the next steps. If continuity is not established, it signifies an internal short circuit along the VTC in wire, which requires repair to restore proper functionality and prevent further diagnostic complications. The final troubleshooting step examines the integrity of the VTC in wire to ensure that it is free from any breaks or opens. Maintain the vehicle in the off mode and check for continuity between two specific test points. Test point 1 at the VTC Oil Control Solenoid Valve A connector pin 1, and test point 2 at the PCM connector E, ADP pin 64. If continuity exists, this confirms that the VTC in wire is functioning appropriately, and there are no interruptions in communication between the solenoid and the PCM. The next step would be to consult any authorized service information linked to DTCs or symptoms observed, or potentially substitute a known good PCM to validate if the original PCM was at fault. Alternatively, if no continuity can be found, It indicates an open circuit within the VTC in wire, and repairs will be necessary to restore proper connectivity to address the P0010 code effectively. After completing all troubleshooting steps and making necessary repairs for DTC P0010, a final verification of the repairs is essential to ensure the issue is resolved effectively. Begin by clearing any stored DTCs using the HDS, ensuring the engine control module, ECM, has a clean slate to work with. Next, start the engine and monitor its operation for any rough idling or abnormal noises. Confirm that the engine runs smoothly without issues related to timing or performance, indicating successful intervention. Finally, perform a test drive under varied conditions to confirm no new DTCs arise during operation and that the vehicle operates reliably. Successful completion of these steps denotes effective resolution of the DTC, ensuring optimal engine efficiency moving forward. Preventive maintenance plays a key role in minimizing the likelihood of experiencing issues linked to DTC P0010 in the Honda Civic. Regular oil changes are crucial, as clean and adequately maintained engine oil ensures effective lubrication and operation of the VTC system. Additionally, periodic checks of the VTC solenoid can identify wear or damage before they escalate into malfunctions. Inspecting the wiring and connections linked to the VTC system can help catch any fraying or corrosion that may lead to intermittent failures or shorts. By committing to these preventive measures, vehicle owners can significantly enhance overall engine performance and reliability, virtually eliminating the occurrences of related diagnostic trouble codes. In conclusion, understanding the purpose of the VTC system and the potential implications of DTC P0010 is vital for any Honda Civic owner. It's essential to follow detailed and systematic troubleshooting steps to accurately identify and resolve issues related to the VTC oil control solenoid. Each step is necessary for diagnosing the root problem effectively and restoring optimal engine performance. Moreover, engaging in preventive maintenance practices not only aids in maintaining reliable vehicle operation, but also extends the lifespan of critical components such as the VTC solenoid. Ultimately, staying proactive in maintenance and comprehensively understanding how to troubleshoot engine symptoms can contribute greatly to a seamless driving experience, enhancing the vehicle's longevity and overall satisfaction. Please like and subscribe to the channel. See you next time.